This is a very particular kind of question that we're going to solve here. I've heard of it popping up on like college entrance tests, um, or like maybe not the SATs, but a test like that. Not that we don't really have those in Canada, but people do still take them. Um, so it's very specific and particular. And once you've solved one, you've solved them all because they're all done the same way. So we're not doing a bunch of these afterwards, but it is a type that you should be familiar with and you should know how to do. So we're going to do one example together. But there's some really, really, really important thinking. I'll be honest with you, it's kind of hard, okay? But some really important thinking that goes along with it that's going to help us with the activity that we're going to do and sort of the activity on problem solving that we're going to do. So Jane and Bill are raking their backyard together. It takes Jane X minutes to rake the yard by herself, and it would take Bill 20 minutes longer than Jane. So one thing I notice in this question, again, that's different from the other ones that you're going to solve on your own, is it gives you X, gives you what X represents. If it didn't give us that, you know from previous years that determining what X represents is a very important first step in solving a problem. And in fact, a lot of students, I think, resist to some extent doing that because they just find it a pain writing a sentence. They just want to get down to work. But something that I've come to realize is determining what X represents is actually an important step of the problem-solving process. It gets your brain thinking about relationships between X and what it represents and sort of the other information that you're given. So I encourage people, mostly starting in grade 10, if you're stuck on a problem, well, a really good first step is what does X represent? Like think about that and think about the relationships. And does anybody know if you're not sure what X represents, like where would you start? What would you do? What might X represent? Anybody know? My rule of thumb, go ahead. There you go. My rule of thumb, 99% of the time, the thing you're trying to find. So you go to where the question mark is. How long does it take each of them individually? So X represents how long it takes Jane individually, and Y, if you're doing two variables, which we're not really, but you could. But ultimately, we're not using two variables in this. But Y is how long it takes Bill individually. See? So 99% of the time, there's sort of one like grade 10 question where that doesn't happen. It's the revenue type questions. Otherwise, almost every question you do in mathematics in high school, X represents the thing you're trying to find, the thing you're being asked to find. Okay, so that's a really good rule of thumb, and it actually can get the ball rolling. And for the activity today, it can be very, very important. Okay, but in this case, we're given it. It takes Bill 20 minutes longer than Jane. If they can complete the job in 7.5 minutes working together, how long does it take each of them individually? So I'm still going to write this down. Just you wouldn't have to if it's given to you, but in the ones that you're doing today, you're probably going to start with this. Let X be how much time it takes Jane to rake the backyard by herself. Then, what can I say about Bill's time? This is something else that can be important. Yeah, X plus 20 is how much how much time it takes Bill. So I think I mentioned this. Some of what you're going to be asked to do today is hard and it will take some time, but that's the point. Okay? Because if you remember back to grade 10, when we had you solving problems, what did we do? We showed you each type, and we said, this is this type, this is this type, this is this type. Memorize each of them. Now go and practice until you can do each of these types. And then on the test, we ask you those types. No, not mine. That's Peter's maybe. I think it's Peter's. Thanks. Yeah, that's fine. Right? We asked you one of those types specifically. That's not really problem solving. That's not. I mean, it's a good start, but that's not really ultimately much problem solving. It's just still memorizing types of questions. So we're going to look at different kinds of questions today. We're going to kind of try to figure them out ourselves. This is a particular type, and I would say it's harder for a particular reason than the next ones that are coming up. So I would not expect probably anybody, not even maybe a math teacher, to be able to figure this one out on their own. There's a step that's very, very difficult. Okay, that's one thing that you should know. But another thing you should know is what unit are we in right now? Rational functions. So our equations are going to be rational equations or rational expressions or rational functions, like they have to be. What makes something a rational function or a rational expression or rational equation? I think we already talked about this last week, or earlier this week. What makes something rational? Yep. You got an x in the denominator. So if you're working on this activity today and you don't have an x in the denominator, you're doing something wrong. And I will tell you that it's very interesting how your brain will automatically be like, well, I don't think I have to solve this with rational. I think I can just do this. You can't. Okay, you can't. I mean, a couple of them, there are different ways you can solve it, but with multiple variables. But that's not how we're doing it. So, and in this case, the natural thing is, well, isn't it just x plus 20 equals 7.5? Like, isn't that just what it is? Isn't that simple? Well, no, it's not. Okay, you do need to come up with a rational expression. So that's our first tip. One thing that you're going to think about as you're working through the activity today is you got to have an x on the bottom, probably several. Okay, so that will help. Then the next tip is, if you believe that x, don't write this down. I already told you this is wrong, but this is what everybody does. Isn't it this? I take Jane and I take Bill, and that's how much it is together. Well, if it was like money in their pocket, then yeah. But if you start to think about what this represents, the meaning of that mathematical sentence, it does not make any sense. How long it takes Jane plus how long it takes Bill working together is how long it takes them together? Why is that wrong? So if it takes me 10 minutes to do something and it takes you 30 minutes to do something, we add those together, and together it's going to take us 40 minutes?
That would be as if one person did it, then another one did it again.
Yeah. Right. Exactly. And they each did half, but that doesn't even make any sense, because it's giving us the information how much it would take them individually to do the whole job. So I did the whole job myself, and then I guess undid it, and then I left, and then you did the whole job yourself, and together we've done it together. Like, that's right. That's not what is happening here. So our brain sometimes fools us and tricks us, and it can be very hard. But I can't tell you how important this is. It can be a really useful problem-solving skill, whether you end up in some kind of mathematical field or anything science-related or anything where there's any math involved, statistics or anything. When you have an x, what does that x represent? Like, being able to wrap your head around that is so important. And so this doesn't make any sense. And also, solve it. Just quickly, I'm going to get 2x, and I'm going to subtract 20. Well, I'm going to get a negative. Well, what? Wait, does that make sense in our answer? I'm going to get one answer, and it's negative. Doesn't make any sense. There's so many reasons why this is clearly not going to work. So let's get rid of it. So here's the hard part. So what would work? Well, I already told you something over x. And then the question is, well, what over x? And in this case, it's something even harder. But in the case of what you're going to work on, you might take the numbers over x, like the numbers that you're given over x, and think about what that represents. I think that's going to be a really important tip to be successful in the questions that you're going to do on your own after. If I tried that here and I did 20 over x, what would that mean? That would mean the length of time that it takes Bill that's more than Jane over Jane's time. Like, I don't think that's useful. Or if I did 7.5 over x, again, I don't know what the time it takes them together divided by the time it takes her on her own. So it's like the ratio of the total time to the time it takes her. I don't think that's really going to help. So what's something else that we could try? Anybody have any gut feeling or idea? It's hard. Just because it's hard doesn't mean it's not worthwhile, or it means you can't do it or you shouldn't think about it, but it's hard. What's another way I could write, like just a random guess, it may or may not be right, but I could write x, but as a rational expression. X over x plus 20, interesting, or x plus 20 over x, interesting. Again, if I divide them, is that going to help? Now, it would be hard for you to tell. Because I know the answer, I can actually think about it. I don't think that's going to help us in this case. That's an interesting idea. What else? Anybody have anything? Any other ideas? How can I turn x into a rational expression? How about 1 over x? Was anybody thinking of that? Were you? So share next time. Good, very good. How about 1 over x? But what does that mean? This is really, again, this is tricky stuff. But I encourage you to try to make sense of this before you move on. What does 1 over x mean in this situation? Well, x is the amount of time it takes Jane, the amount of minutes it takes Jane to rake the yard by herself. So what do you think x might be? Like, it could take her 100 minutes. I know we have no idea how big her yard is. But working together, it takes them 7.5. Can anybody guess at what ballpark maybe it might be? Again, this is a good problem-solving skill. Somebody shout out a number. I'm not even an estimation. It's just like random. 10. Thank you. So if it took Jane 10 minutes, what's 1 over 10? 1/10. If it took her working by herself, it took her 10 minutes, what's 1 over 10? 0.1. Emily, what do you think? You a look on your face, you thought of something? No? No? What's 1 over 10? 1/10 of the job, right? 10 minutes, 1/10 of that is 1 minute. So 1 over 10 would be like 1 minute's worth of work. Because she does 1/10 and then another 10th and then another 10th, and she does it 10 times and she's done the whole job. 1 over 10 is 1 minute of her working. Right? And then it would take Bill 30 minutes because it takes him 20 minutes longer. That's a lot longer. Bill's very inefficient and lazy. So it would be 1 over 30 because it would take him 30 minutes. So 1 over 30 is how much he could do in 1 minute. Right? Does that make sense? 1 over 10, how much she could do. 1 over 30, how much he could do. In 1 minute, because I've divided by the total number of minutes. I've divided a whole by the total number of minutes. So then I can think of this. So 1 over x is the amount of work Jane does in 1 minute. So folks, that's hard. This is, and remember I said that's probably not something that I would have expected any of you, or even like a math teacher, quite frankly, to figure out on their own. That's like that. You're kind of pulling this out of a hat, out of nowhere. You know what I mean? But the ones that you're going to do are a little bit easier. And thinking about what that part represents, 1 over x, what does that represent? Before I even write an equation, I think that's going to be really helpful in solving these problems. So that's what I would encourage you to do. Like your first steps in these problems are going to be, what does x represent? Try to come up with some kind of just simple rational expression, not an equation yet even. You could try, that's fine, do what you want, but just come up with one part and think about what that represents. If I take this and divide by x, what does that mean? So in this case, 1 over x is the amount of work that Jane can do in 1 minute, right? If it was 10, 1 over 10, she's done 1/10 of the job. If it was 20, she will have done less, because it's going to take her 20 minutes. And you'd have to add up 1/20th 20 times to get the whole job done, right? If you can kind of break it apart. Another really good tip is, if you're stuck, pick numbers for x and plug them in and see if that helps you make sense of what it is you're thinking about or looking at. That can help. Well, what if x was 10? And then start thinking about it that way. But then remind yourself x isn't 10, we don't know, so then you just take the 10 out and put the x back in. And 1 over x plus 20 is the amount of work Bill does in 1 minute. Oops. And then the last part to problem solving that I think will be really helpful is, how do we come up with an equation? Well, when you think back to grade 10 and all of those quadratic word problems, that's when we start solving interesting word problems. Grade 9 we do them, but they're not interesting. Grade 10 we do them, they start getting interesting. It's always like something plus something equals something, right? It's always, or something minus something maybe, but two things totaling. So the total of these two, or the difference of these two. Like it's always this plus this is this. This minus this is this, right? Every equation has to work out that way. It very rarely was just this equals this. So I'm not going to do 1 over x equals 1 over x plus 20. And remember what we talked about before. You can't take how long it takes her and add how long it takes him, and that's going to make something meaningful. Like that's not going to help us solve the problem. But what will solve the problem? How much she can do in a minute plus how much he can do in a minute is what?
How much they would do together in 1 minute.
And how can I come up with an expression for that? Remember I said it's not going to be one thing equals the other. So let's just say I kind of random guess and I do this. What would that add up to? How much they can do working together? Because now that's something that makes sense to add up. How much Jane can do in a minute plus how much Bill can do in a minute is how much they both accomplished in a minute together. Can we come up with an expression for that? How much they've done together in a minute? Anybody have a guess? And another problem-solving trick is sometimes like really just wild guess and think about it and see if it works is a way to get moving. If you're all the way stuck, how do you move forward? Wild guess, stick it in there and start working out and see if it works, see if it makes sense, see if it gets you somewhere. Oh, it's wrong, but now I think I have the right answer, right? Sometimes you do something, you think about it, and that just helps you get to the right place, even if your original thought was wrong. Is it going to equal 7.5? No, why not? And 7.5 is the whole time. So what would it be? Do you think the 7.5 has anything to do with it? It kind of has to, doesn't it? Wild guess?
I'm thinking about the whole like 1 over x
Uh-huh.
up to 7.5. So like if you find 150 in minutes together and that's 150 in a minute, like
Yeah.
7.5 minutes.
Yeah.
Like I don't know. I'm just
So what would it be?
I don't know. I don't wanna. I don't know how to express what I'm thinking.
Okay.
You mean like 1 over 7.5?
Yeah. So basically, like that gives us how much.
Isn't it? If 1 over 10 is how much, supposedly, if she was 10, 1 over 10 is how much she can do in a minute. And it's 7.5 minutes, and it's 1 over 7.5 is how much they can do together in a minute. So her amount of work plus his amount of work equals their total amount of work in 1 minute. Like we were able to use rational expressions to come up with two things that we can add together and turn them into things that we can add together that make sense. So as I said, if you ever had another question, there's one in the review, by the way, I'm going to hand it out today. There's one like this in the review, so you'll get a chance to practice it. They're all the same. Like the working together questions are all the same. Now that you know how to solve it, it's just 1 over x plus 1 over x plus whatever equals 1 over whatever the total is. Like every single one is the same. Okay, so this is a grade 10, like formulaic kind of, this is how we solve these. And as I said, I've heard of them coming up, students that have graduated, left, and returned and said, ooh, I had this question and I didn't know how to do it. So it's maybe useful to one of you someday or somebody to know how to do this. But also, the noticing how rational expressions, like thinking about a something per something and adding it together, changes compared to just adding them together. And if you're going to take calculus, we build on that a lot. We have a whole unit on rates, and it's like big time sort of thinking about what you can add together and what you can't add together. Okay, so then we could go ahead and solve this. Let's do it. So this is going to be 7.5 times x plus 20, because I got to multiply everything through by all the denominators, plus 7.5x equals x times x plus 20. So I get 7.5x plus, oh dear, what's 7.5 times 20? 750 times, 75 times 2, so 150. Plus 7.5 minus, no, I'll go do equals x squared plus 20x. So 7.5, and 7.5 is 15. I'm going to move everything to the side. And so that's going to be 15, so plus 5x minus 150. Factor this. That's funny. So x is negative 15 and x is 10. Look at that. X is 10, just like we guessed all along. That wasn't on purpose. And you can't work a negative number of minutes, so this one is inadmissible. And so it looks like Jane actually can do it on her own in 10 minutes, and Bill then can do it on his own in 30 minutes. Write your conclusion sentence and you're done. Any questions about that?